Hello, good morning students. Today we'll discuss about the Bohr's effect. The Bohr's effect is a physiological phenomena first described in 1904 by Danish physiologist Christian Bohr, stating that hemoglobin's oxygen binding affinity is inversely related to both acidity and to the concentration of carbon dioxide. An increase in the blood carbon dioxide concentration, which leads to a decrease in blood pH, will result in hemoglobin protein releasing their load of oxygen at the level of tissues. Conversely, a decrease in carbon dioxide provokes an increase in pH, which results in hemoglobin picking up more oxygen, since carbon dioxide reacts with water to form carbonic acid, which immediately breaks into hydrogen ion and bicarbonate ion, and increase in carbon dioxide result in decrease in blood pH. One of the factors that he discovered was pH. He found if the pH was lowered than the normal value is 7.4, means it is less than 7.4, then hemoglobin does not bind oxygen as well. This is shown in the following percentage saturation graph. So this is the hemoglobin saturation curve. At 7.4 we can see the red line, whereas at 7.2 it shifts towards the right, that is at more partial pressure of oxygen the percentage saturation it is achieved. So in the lungs, partial pressure of oxygen is almost 100 mm of Hg and hemoglobin is 98% saturated at both pH 7.4 and 7.2. Thus, the binding of oxygen to hemoglobin in the lungs, very important, in the lungs is not affected by changing the pH, and oxygen will load normally. The situation is different at the level of tissues. The change in the pH result in a lower percentage saturation of hemoglobin, even though the partial pressure of oxygen in the tissues has remained to be 40 mm of Hg for this example. So percentage saturation at pH 7.4 with partial pressure of oxygen at 40 mm of Hg, it is about 70%. What it means? It means that 30% of oxygen coming to the tissues is released. At pH 7.2, the value is close to 60%, which means 40% of oxygen coming to the tissues is released. Thus, more oxygen is delivered to the tissues at lower pH, even when the partial pressure of oxygen remains unchanged. Lowering the pH appears to shift the entire red curve towards the right. If we were to design an oxygen delivery system, we would like to deliver more oxygen to more active tissues, the ones that need more oxygen. How would we know that if a tissue is more active and requires more oxygen? One way is by the amount of oxygen present in the tissues. If the tissue is using more oxygen, then one would expect the amount of oxygen would be lower. Another indicator that a tissue has high metabolic rate. Thus, a need for increased oxygen delivery is the production of carbon dioxide. When a tissue is more active, amount of carbon dioxide produced will be increased. So partial pressure of carbon dioxide is higher in more active tissues. So carbon dioxide reacts with water to form H2CO3, which breaks down to form hydrogen ion and bicarbonate ion. What this means is that as the amount of carbon dioxide increases, more H ions they are formed and the pH will be decreased. Thus, lower pH in the blood is suggestive of increased carbon dioxide concentration, which in turn is suggestive of more active tissues that require more oxygen. So, according to Bohr, lower pH will cause hemoglobin to deliver more oxygen. So, when the pH is less, oxyhemoglobin curve shifts towards right. This is Bohr's effect. Now coming to the physiological role of the Bohr's effect. This effect facilitates oxygen transport as hemoglobin binds to oxygen in the lungs but then releases it in the tissues, particularly those tissues which need more oxygen. When a tissue metabolic rate increases, its carbon dioxide production also increases. Carbon dioxide forms bicarbonate through the following reaction, that is carbon dioxide plus water forms H2CO3, which dissociates to form hydrogen ion and bicarbonate ion. Although the reaction usually proceeds very slowly, the enzyme family of carbonic anhydrase, which is present in the RBC, accelerate the formation of bicarbonate ion and proton. This causes pH of the tissues to decrease and so promotes the dissociation of oxygen from hemoglobin to the tissues, allowing the tissues to obtain enough oxygen to meet their demands. Conversely, in the lungs, where oxygen concentration is high, the binding of oxygen causes hemoglobin to release proton, which combines with bicarbonate to drive off carbon dioxide during the exhalation. Since these two reactions are closely matched, there is a little change in the blood pH. So, the dissociation curve shifts to the right when carbon dioxide or hydrogen ion concentration is increased. This facilitates increased oxygen dumping. This mechanism allows for the body to adapt the problem of supplying more oxygen to the tissues that it needs the most. When muscles are undergoing strenuous activity, they generate carbon dioxide and lactic acid as the product of cellular respiration and lactic acid fermentation. In fact, muscles generate lactic acid so quickly that pH of the blood passes through the muscles will drop to around 7.2. As lactic acid releases its protons, pH decreases. This causes hemoglobin to release about 10% more oxygen. So this is the Bohr's effect. Thank you.